Yeah,
Do you have new seats right now?
Did I do? Mostly
Why
at
would
my
you-
colleges and clean my room.
3 days of cleaning your room, it must have been dirty.
I cleaned my room for one of the days, and then I was applying to colleges the rest of them. So
Let's go.
Oh, wait, that looks like a mistake.
I'm just about Where are you? You're here.
Y'all can blame Fei Fei because she keeps
Wait, it's
looking.
actually not bad. I'm with Owen. I should work well.
Well, of course, I try to pair you up with people you can work with.
Has this finally come? Yes! Yes!
My physics test got pushed back
Me
to
and
Monday.
Patty are together.
Bro,
Wait,
Oh, no, just
Sorry. No, the NCQ did this thing.
there you go.
Oh, really?
Oh yeah.
cool. This is the same,
Wait,
except like, kind of like,
There's number 2, bro.
Not the same. It's a little different.
well, I'm made of the same people besides him.
What's your
Yeah,
location?
1 and 2.
It's not. There's nothing wrong.
Wait, I sit on
I said on 1.
That's just my name. My name's.
Wait, go on the right side. Look at the right.
Oh, I see.
Yeah.
That has nothing to do with
Wait, so
this
I'm
side.
11?
But it is fine.
No.
No, just that side and that side. I think.
Isaiah.
Right side and the left side. Left side number
I
2.
saw him last time. I should have talked to him. But
I don't remember what my game
I remember what he was. I can
No.
let's look good.
I think you're.
You guys
Yo.
see different
I
stuff.
think he's.
Come to our side.
Huh?
Come to our side. So,
Yeah.
come to our side.
I have one of my own.
Or just come to our
I'm the host of it.
Oh.
Wait, dude, everyone went the same way?
Yeah, there's only one.
Like half, or half of the road. Okay, there you go. I needed someone to give it to.
Wait, me and Jen just have one.
Share it out.
There's no way.
That was updated. You're there.
Well, you're 26 now.
Wait, we're 26 right now. 28. Why did you switch?
I didn't switch. The numbers were messed up.
I was number 3. Oh, never mind. I now have to move with you.
There's not. You should have known that there wasn't 2 number 1s and 2 number 2s and 2 number 3s.
I have a message from Lana. She says that absolute maximums and minimums were boring and that she almost fell asleep in her class.
Okay. Well, that'll be the last time that happens.
Okay.
We just learned like R.
All right. Find your new seat. Take a seat and find your handout.
Is there a book assignment out to do tomorrow? It's on the website.
With Patty and stuff. Patty, Patricia. Here.
Can I go to the restroom or we have to?
We didn't actually
10 minutes.
explaining everything.
Oh yeah, for sure.
There wasn't a way you would, unless you looked up like a YouTube video.
All right. Take a seat, please. We can get started. Okay, we are going to continue on the worksheet we started last class, which is 35, so you already have that. Please find it.
My physics test got pushed back to Monday. That happened to stay up a
All right, so I promised that our next seating chart will come sooner than this one came, but the main reason I like to switch it up is just for some variety here, but I am very strict about, I try to pair you up with people that I think you will work well together and people that you might want to work with. But of course that depends on a lot of things, like do you work well with them? Are you getting your assignments done? Are you able to start class with us when it's time to start class? Can you not talk when you're not supposed to be talking so that you don't get the seat out in the hallway? Stuff like that. So keep that in mind, because once you lose that, then this is your one chance. Okay, so last time we started talking about some polar stuff, so let's go ahead and spend 2 minutes reviewing the stuff we talked about last time. Practice a couple more, or practice one more question together, and then I am going to do several of these with you as guided practice, because some of these I think are a little bit harder than what we've been doing. But polar, we've got this rectangular coordinate system, which is x, y, whereas polar is r theta. Go ahead. So instead of going this far left and right and this far up and down to plot the point, you go this far in this direction to plot the point. The formulas that we will need to use is to go from polar to rectangular. X is r cosine, y is r sine. How did I tell you that you might be able to keep these two straight? Right. Unit circle cosines the x values, unit circle sines the y values. So that can help you with that. And if you want to go the other way, if you need to know the angle, you could do inverse tangent of y over x. Or if you needed to know the radius length, you could do the square root of x squared plus y squared. Basically Pythagorean theorem. So the couple that we did last class is we converted these from polar to rectangular. So if we saw r cosine theta, we changed it to an x. R cosine theta, we changed it to an x. R squared, same thing as x squared plus y squared. And then number 3, we had to do a little bit, multiply both sides by a denominator, distribute the r. Then r cosine theta becomes x, r sine theta becomes y. Now, the derivative, so when we need dy dx, that is the derivative of y over the derivative of x. But since y is r sine theta, to take its derivative, you have to do product rule. Derivative of r with sine left alone plus r times the derivative of sine over the derivative of x. And since x is r times cosine theta, that would be the derivative of r times cosine minus r times the derivative of cosine. So it's not quotient rule, it's not the derivative of the whole thing, it's just the derivative of the numerator over the derivative of the denominator. Now, I don't think you should memorize this, but at the very least you need to recognize that when you need dy dx, you're probably going to have to do some product rule. Product rule for the numerator and or product rule for the denominator. Okay, then we looked at question 4, where we needed to find the slope of the tangent line. So I found dy dx, the way I just talked about right there. R was this, so there was r prime. Plugged all that stuff in. The derivatives, dy dx, can look pretty scary in a lot of these questions, but a lot of times you're just going to plug in 0 for theta, or pi over 2 for theta, or pi for theta, stuff that makes a lot of this stuff just go to 0 anyway. So we did that one last class and got to 1/2. Now, on to question 5. This one is probably the one that takes the most amount of work. Can you close that, please? Thank you. This one's probably the hardest one on this entire worksheet, in my opinion. There's a lot going on here. But, I don't know, it makes sense to do it now before we kind of reset and start off with the easier ones. Okay, so when would you have horizontal tangent lines? Okay, when your slope is 0, just the same thing as when the derivative is 0. And when would you have vertical tangent lines? Okay, so if your first derivative is 0, you've got horizontal tangent lines. If your first derivative is undefined, you've got vertical tangent lines. Okay, we've heard that lots of different times. Now for this question, to do that, I need to find dy dx. which from the last two questions is y prime in terms of theta over x prime in terms of theta. And I'm not going to try to write small here. I'm just going to erase some of my work. So make sure you're following along here. So for the numerator, if I need the derivative of y, we're going to start off with what y is equal to r sine theta. We can plug in what r is equal to for this question, 1 minus sine theta. We could distribute the sine theta, and then I'll worry about the derivative. The derivative of sine is cosine. This one you need to be careful with. This is power rule. Bring the power down, lower the power by 1, and chain rule. Derivative of sine is cosine. Okay, so all of that makes up the derivative of y. Now notice, I'm going to erase this in just a second, but this is how a lot of questions start off. And starting in some of these questions is going to be the hardest part. I started with the formula that we're going to use. I plugged in the r that they gave to me. I distributed or tried to make it look as nice as possible before I did the derivative. Okay, now I'm going to do the same thing for x. But if you could do that one, you can certainly do this one. X is r cosine theta. R in this question is 1 minus sine theta. It's right here in the directions. I could distribute or do any simplifying that I can before I take the derivative. And then within the derivative, you need to be careful that you're doing product rule here. Sine times cosine won't simplify in any way, but we could take the derivative of sine times a cosine, and then the derivative of a cosine times a sine, and we currently have negative, actually distribute this, we've got a positive sine squared, we've got a minus sine theta, and we've got a negative cosine squared theta. There's a problem with that, but we'll see what the problem is later. Okay, so that's how you go about finding dy dx. You got to start off with y equals, plug in r, take the derivative. Start off with the x formula, plug in r, take the derivative. Derivatives are a little longer and messier, and again, I'm just erasing my work here so that I have space. Are you guys okay with how I found the x and y derivatives? Okay, so if I want to know where this is horizontal, then I want to know where this equals what? Okay, and when does a fraction equal 0? Okay, so let's set the numerator equal to 0. And what algebra step would we have to start with to solve this? Distribute?
Or associate. Like
Distribute is the type of multiplication.
Like just like
You want to undistribute, which is called factoring out of GCF. Since
is that
it's
not associated? Is that associated? Am I getting it?
Associative property says that A times B times C is the same thing as A times B times C. Okay, so I could figure out where cosine is 0, and I could set this equal to 0 where sine is 1/2. So where is cosine 0? Okay, and 3 pi over 2. Cosine's the x value. Don't look at the graph right now. The graph's not important yet. There's 2 places where cosine's 0, and there's 2 places where sine is 1/2. Sine is 1/2 at pi over and and 5 pi over 6. You're going to need a lot of unit circle here, so good review. Okay, so it looks like there's 4 places that have a horizontal tangent line, because that's where the derivative equals 0. That's actually not true. So I'm going to erase this again just for space. So for these questions, I don't know of a way to do this by hand. I'm going to check a couple more sources, but the first 2 that I checked said that you needed a graph to compare these. So look at our graph here. Ignore all this work. How many places do you think this polar equation has a horizontal tangent line? Is this one of them? And this is horizontal? And this one? Good. But we said 4. So one of these we shouldn't keep. So think about this angle. This angle going this way, which one of these is that probably going to be? 5 or 6, the only one that makes sense. Which one would be that angle? Okay, and then to get down to this one, that's probably going to be 3 pi over 2. So at pi over 2, notice there's not a horizontal tangent line. It's actually, there's a cusp there, so you can't even take the derivative there. So again, as far as I know, that's the only way to know which ones to keep and which ones not to keep. But I will check another source before I see y'all again. Okay, so that was just for the horizontal ones. Also, where's the undefined? So undefined is when the denominator would equal 0, and I am equals 0. I'm concerned about solving this. How are we supposed to solve this when we've got sines and cosines mixed together?
You could simplify the sine squared theta minus cosine squared.
Sine squared minus cosine squared. Oh, okay, yeah. I didn't even do that, but that's pretty smart. Let me tell you what I did, but I think what y'all said was better. I took this and I changed it to 1 minus sine squared, because then I have just sine stuff and I could solve it with factoring. But let's try saying if sine squared plus cosine squared equals 1, then if I subtract this over, sine squared is equal to, oh wait, well we actually can't get those.
Yeah.
If this is positive, there's never this is positive and this is negative, is it? I could subtract this over, but
So I said that.
okay, so your way didn't work.
Yeah, that's nice.
It would have been easier, but okay, so instead of cosine squared, let's say 1 minus sine squared. That's too bad, because that's kind of a pain. Now when I distribute this negative and combine it with this sine squared, I've got 2 of those. I've got a minus 1 sine and a minus 1 when you distribute that. And now it doesn't really look like it, but since it's all sine stuff, this factors. 2 sine times sine gives you 2 sine squared. A minus 1 times a plus 1 foils to give you a minus 1 at the end. And if you FOIL this, the outer and the inner combine to be minus sine squared. So where sine is negative 1/2 and where sine is 1 are the places where we might have vertical tangent lines. So where is sine negative 1/2? Good, 7 pi over 6 and 1 more. Okay, 11 pi over 6. And where is sine 1? Okay, pi over 2. Okay, but now look at your picture. How many vertical tangent lines does it look like we have? I just see 2. 1, 2. So one of them is at this angle. Which one of these 3 do you think that is? Okay, so let's keep it. The other one is this one. Okay, so once again, We should not be keeping pi over 2. There's 3 places that have horizontal tangent lines and 2 places that have vertical tangent lines. Again, I don't like that you have to think about the graph to be able to do that. I really feel like there should be another way, but I've not seen that yet. So there's a lot going on in this question, but the overall process is what's important here. How to find the derivative, y prime over x prime. To get y prime, take what y is equal to, r sine theta, plug in r, take the derivative. To find x prime, take what x is equal to, r cosine theta, plug in what r is equal to, and take its derivative. Horizontal tangent lines occur when the derivative is 0. Vertical tangent lines occur when the derivative is undefined, so we had to solve those 2. And we had to think about which of those numbers made sense with the graph to know not to keep pi over 2. But again, I think that's probably the hardest question. Is there anything you would like to clear up while we're still here?
Wait, isn't the slope undefined? Pi over 2? Because I don't really get why we're excluding that from non-defined.
Because right here, that's not a vertical line right there. It's nothing. The slope of, this is where pi over 2 is. So it's this little cusp right here. There is no, you can't say that there is any slope there.
Thank you.
That's not a very satisfactory answer, which bothers me as well. I understand that, but generally, there's only a couple questions that come up like this. Look at where there's obviously horizontal tangent lines, keep those. Look at where there's vertical tangent lines, keep those, but you shouldn't be keeping any of the rest. Okay, so kind of resetting here, back to what should be much easier, and then build up to that. These are the questions. So again, I would like to do like 7 or 8 of these with you as guided practice, but you should try this one on your own first. This is giving you, it's wanting rectangular coordinates. So it wants you to write your answer as x comma y, but it gave you polar coordinates, which is r comma theta. So think about if you know r and theta, how are you supposed to get x and y? And I would like you to try that. If you get this, you can move on to the next question a little bit early. And if not, I will go over it in just a minute. But of course, these are the skills that are going to build up. So any of these that we're struggling with, we need to iron out fast. Okay, I'll get it.
I think it's me for Tuesday and Wednesday. They would have both days.
One day is fine.
I got Wednesday.
It's got to be Tuesday.
Okay.
Tuesday is the math priority day.
Okay.
You want me to take you off for Wednesday?
Yeah.
Okay. I can do that.
Thank you.
Okay. If you did not come up with that for number 1, what you should have thought about was x is equal to r cosine theta and y is equal to r sine theta. So 7 times the sine of 5 pi over 4 ends up being 7 times negative square root of 2 over 2. And then for y, r sine theta ends up being 7 times negative square root of 2 over 2. And so that's why the x and the y were the same.
Oh.
Okay, is that enough for number 1?
Excuse me, thank you.
Okay. You will need a calculator for number 2 and one set of possible answers is now on the board. So let's give everybody a few minutes to try it, and then I will explain why those answers are possibilities.
Or is it just positive?
Do you understand?
I don't know if I got it right.
Okay, I'm going to erase my answers to number 2 and then go over it. So if you didn't figure that up, which I figured this one probably held you back a little bit, especially those of you that skipped pre-cal, this one's a little bit harder. Okay, find 2 sets of polar coordinates that match this. So polar coordinates are supposed to be r comma theta. Okay, please work independently if you don't need help with this one. So to find r, you could use the formula r squared is equal to x squared plus y squared. So r is the square root of 16 plus 4, which is the square root of 20, which is the same as 2 square roots of 5, which is where part of my answer came from. I'm assuming y'all figured that part out. Yes? Okay, for theta, you look at your formulas on the front page. There's only 4 of them that you need to be actively looking to use. You could do inverse tangent of what over what? Okay, so y over x. You do that. You can throw that in the calculator. Your calculator needs to be in radian mode. You get negative 0.464. Now, I know you got this, but how come I didn't use this in one of my answers?
Theta has to be between 0 and 2 pi.
Right. A negative is not between 0 and 2 pi. So, here's the part where I was saying that if you skipped pre-cal, this is a little bit harder. If I draw a unit circle, a negative radian, this is almost negative, this is almost 0, but it's on the negative side, is about right here. Where on the unit circle is there a tangent value that has the same, that also has a tangent of negative 1/2? It is in quadrant 2, but how do I get to quadrant 2? Okay, my next hint, look on your desk. One of those circles has the tangent values. One of the patterns to that, like at pi over 4, tangent is 1. Where else is tangent 1? Okay, at pi over 6, tangent is square root of 3 over 3. Where else is tangent square root of 3 over 3?
7 pi over 6.
Okay, what do those angles have in common? Right, so look at that circle because this will make more sense. For tangent values, if you have a tangent value, like this guy has a tangent of negative 1/2, halfway around the circle has to have the same tangent value. Just like on that. Where tangent's 1, halfway around the circle, tangent's also 1. Where tangent's negative square root of 3, halfway around, tangent's still negative square root of 3. So how do I go halfway around? Okay, you could add pi. So if I add pi, this gives me 2.678. That's one of my answers, but it said come up with 2. Now, if you subtract pi, you're just getting more negative, which is more outside of it.
3 pi. 3 pi.
Okay, no guesses.
3 pi.
That's your answer for the test.
What? Yeah.
Okay, it's not 3 pi. Okay, the other one, you need to remember that r can be negative. So going 2 square root of 5 in this direction is the same thing as going this direction but negative 2 square roots of 5. That when it's going negative, it's actually going back this way. But we could have also just added 2 pi to this because we want to go this direction, but in the negative way. So that would be, oops. That's where the 5.820 came from. That's not the only 2 answers. There's actually infinite number of angles. Well, actually I take that back. Since it says 0 to 2 pi, I guess there's not an infinite number. But r can be positive or r can be negative. Going 2 square roots of 5 in this direction is the same thing as going negative 2 square roots of 5 in that direction, because the negative makes it go the opposite way. So r can be negative. Okay, 3 and 4 are both considerably easier, but is there anything else you'd like to clear up about number 2? Good? Okay. So please do 3 and 4. I got 4 and 3.
Try pi 1 2.
Yeah, secant to
And you just plug in or plug in that into
Okay, somebody tell us why r equals 4 is the answer on number 3.
That's 6 square root of 16.
Okay, so actually I got two things to point out about this. When you guys look at this, do you realize that this is the equation of a circle? Because I know that's on your ACT. They expect you to know on the ACT that the center is at 0, 0, what you're subtracting from x, comma, what you're subtracting from y, and the radius is 4. This is radius squared, so the square root of this gives you your radius. You need to be able to do that for the ACT. But think about what this graph looks like. If you center a circle at 0, 0 and give it a radius of 4, do you see that's the same thing as this? This is saying plot all the points where the radius is 4. As theta goes around, it plots all those points. Same thing. These two are saying the exact same thing.
Could r equal -4 as well?
Yeah. You don't need to make it plus or minus because it's redundant. You would be getting the same circle on top of itself. But yeah, r could be -4. That's fine too. It's just that as I go around the circle, I wouldn't be plotting the points in this direction. I would be plotting them in the negative direction. But it's still going to be the same graph, doesn't matter. Okay, and then can somebody tell me why number 4 is x equals 3? Okay, yeah, it is 3. Why is it 3?
R equals to 3 times 1 over cosine theta.
Okay,
And we just times cosine theta on both sides.
okay,
You get 3. That's x.
okay. And then you're done. Good job.
Oh,
Okay, did that clear everything up for 3 and 4? I don't know why those, they probably should have put those at the start because those are easier than question 2 was. Okay, for question 5, I want to give you a bit of a hint because it says without a calculator, so I don't want you to just throw this in your calculator. But I will remind you how to use your calculator that we talked about last class so that we can check it. But just like back in your Algebra 1 days, before you had any idea what a graph would look like, all you could do was plug in an x value, solve for y, put it in your table. Bless you. Pick a different x, solve for y, put it in your table. Pick a different x, solve for y, put it in your table. And then you plot all the table points, and then you can figure out what a graph looks like. That's what you should do here. You should be picking values of theta that you think you can solve. Don't pick pi over 100 because you don't know what cosine of 3 over 100 is. Pick values that you can find the unit circle of, plug them in, solve for r, and then try to plot that point. And that's pretty hard to do, but try to get as many points as you can from 0 to 2 pi. Plug in 0, see what you get for r, and then try to plot that point. And then try the next thing, solve for r, plug it in as a point, and see if you can figure out what this graph looks like. It is not a straight line or anything like that. In fact, if you were paying attention last class, you should know that this has some petals. How many petals is it going to have? It is going to have 3. So that gives you a little bit of a help if you realize why. Just plot your points and see what happens. No, it doesn't. No, it doesn't. Plug in 0. What's the cosine of 0? times 2. 1 point is at 0, 2. So in 0 degrees, 0 radians, you get a point at 2. Okay, how about pi over 3? Pi over 3 times 3 is pi. What's the cosine of pi?
It's gonna be negative.
Cosine of pi
It's -1.
is -1 times 2 is -2. So at pi over 3 direction, which would be like this, you need to go -2. So roughly about there. You could try pi over 6. Pi over 6 times 3 is pi over 2. What's the cosine of pi over 2? Zero. 0 times 2 is 0. So at pi over 6, it's back to 0. You could try pi over 12 times 3 is pi over 4. Cosine of pi over 4 is square root of 2 over 2 times 2 is square root of 2, which is like 0.8 or 0.7. It didn't take that long.
Y'all just need to review the unit circle.
Wait, if it's pi over 3, shouldn't it be like going here?
Yeah, it's a very reason, but it's
It's an R and a negative.
Does it have 3 petals? Is one of them centered around the x-axis?
Are the other 2 like in the middle of quadrant 2 and 3? Okay. If you're not confident, you can always do more points. More points should just reaffirm that it's right. Or you can just come look at mine. Yeah.
What?
Okay. I'm cutting you off even if you didn't have enough time. So these are some that I did, but I mean you can pick any angle that if you multiply it by 3 that you know the cosine of it. And in the end, again, this is why I started getting more points like this. If you start off at 0 and then you do the next one and then the next one, you should do, oh actually it does like this and then this and then like this. So, as far as I know, you don't have to know, well you certainly don't have to know right now that this has 3 petals, but that would make you feel a little more confident that you were doing it correctly. But if you were unconfident in your picture, which as far as I know you guys have never plotted coordinate points, just do more points. More things that if you multiplied it by 3, you would know the angle. So I think these are all the ones that I did, and I felt comfortable here, but you could also do, I don't know, 3 pi over 12, multiply that by 3 would be 9 pi over 12, which is like 3 pi over 4. Cosine of 3 pi over 4 is negative square root of 2 over 2 times 2 gives you negative square root of 2, which is about negative 0.7. So when theta is 3 pi over 12. If you cut this into 12ths, you should get negative 2, which would go the other direction and land about there-ish. So, Okay, I would like to do one more with you on the board. If you just kind of glance, 6, 7, 8, 9, even 10, 11, 12, and 13 all pretty much have the same pattern to the questions. These are a lot like question 4 that we did in the notes at the end of last class. So let me do question 6 for you, because I think one more is not going to hurt you to see, and then that's an easy one for you to apply, and I want you guys to keep going after that. Okay, so when it says find the slope of the tangent line at the given point, I know the slope of the tangent line is going to come from dy dx, and then after I find dy dx, my answer is going to come from plugging in pi over 2 into that, and that's where my answer is going to come from. On these longer type of questions, I actually think of them backwards. If I know my answer comes from plugging pi over 2 into dy dx, then I know I need to find dy dx. If I need to find dy dx, I know that's going to come from y prime in terms of theta over x prime in terms of theta. If I need y prime and x prime, then I'm going to need to know what x and y are equal to, and we know what r is equal to, so we can even plug that in. So here is x and y in terms of theta. So now I can take the derivative of this guy, and since he's only got thetas, he will be in terms of theta. So it's going to be 3 times the derivative of theta times cosine. That's got to be product rule. So derivative of theta would be 1 times cosine left alone, plus theta left alone times the derivative of cosine, which would be negative sine Okay, if I want to do, actually I'm going to put y prime above it. Why do you think I feel better about y prime being above than below? Because that's how the formula is set up, right? So I kind of like to do my work the same way. Okay, so y prime would be 3 times the derivative of theta times sine. So 1 sine plus theta left alone times the derivative of sine, which would be cosine. So dy dx in terms of theta is y prime over x prime. Of course, the 3's can cancel, just like our question examples 4 and 5 on the second page. dy dx can often look pretty scary, but if you really only care about it at a certain point, it's actually it should come together pretty nicely. The sine at pi over 2 is 1. The cosine at pi over 2 is 0. The cosine at pi over 2 is 0. The sine of pi over 2 is 1. And you're very quickly left with 1 over negative pi over 2. And dividing by this is the same as multiplying by the reciprocal. So negative 2 over pi. Find x, find y, plug in r for this problem, take the derivative of each one, put y prime over x prime, and you've got dy dx, and then we just wanted dy dx at pi over 2. So I plugged in pi over 2 into all of that and came up with this as an answer. Okay, so again, that's how most of these are going to go. 7, 8, 9, they're all about the same length as question 6 and have a similar approach to them. So I will, obviously I'm happy to help out with any more of them, but on number 7, make sure you get an answer of negative 1/3 before you move on. And I'll give you several minutes to try that one, since you can see they do take a few minutes. Now, I will also warn you that I did one question earlier today where I'd miss like one negative sign way up here. One time I took the derivative of cosine and I switched the sign twice and messed it up, which then of course threw my final answer off. So it's very important to go slow and accurate here than fast and have lots of careless mistakes. So.
The bottom square.
Okay, does anybody need help with 7? Need to see it worked out? Okay, I'm seeing a couple of yeses. So if you need help with 7, you can follow along with me. If not, just keep going on your own, please. Okay, so this would like me to find slope of the tangent line, which would be dy dx, at the given value of theta. So when theta is 3 pi over 2. So I know if that's my answer, I first have to find dy dx. To find dy dx, I need to find y prime, so I can put it over x prime. And before I can find y prime and x prime, I need to find what x and y are. So y is r sine theta, and x is r cosine theta. Since we know what r is, we can go ahead and make that substitution. We don't need to leave it r if we know what r is equal to. Okay, and then since this is just being multiplied, I'll put the sign up here. Okay, so y prime is something divided by something. I think this was the one I made one sign error, so I'm going to try not to do that today or this afternoon. But it's got to be quotient rule. So 5 times the derivative of sine times the denominator left alone minus the derivative of the denominator times the numerator left alone, all over the denominator squared. Okay, I can do the same thing for x prime. It's going to have almost the same work. It's got to be product rule. I'm sorry, not product rule, quotient rule. Derivative of the numerator times the denominator left alone minus the derivative of the denominator times the numerator left alone, all over denominator squared. And now, when I was working this question a couple days ago, of course I started to freak out just a little bit because I don't want to take this divided by this, although if you do, if you change it to this times the reciprocal of this, the denominators cancel out anyway. But since you really only care about this, you don't really care what the derivative is, you just want the derivative at 3 pi over 2. I just plugged in 3 pi over 2 for this, so that would be 5 times the cosine of 3 pi over 2, which is 0. So all of that goes to 0. So I could care less about the rest of this. Plus the sine of 3 pi over 2, which is negative 1, times 5 times the sine of 3 pi over 2, which is negative 1. So that becomes 5 over 9. 5 over 9. And then I did the same thing for x prime. Again, x prime is pretty scary looking, but if I just plug in 3 pi over 2, I get 5 times 3 minus 0 plus a negative 1 times a 5 times 0 all over 3 minus 0 squared. So all of that comes out to be 15/9. And here's my y prime at 3 pi over 2 divided by my x prime at 3 pi over 2. And of course, to divide fractions, you probably should change it to multiplying by the reciprocal, which eventually gets you down to 1/3. I got negative 1/3. Okay, then I did the same thing I did in first period today. One of these is supposed to be negative. I want to say it's this one. Was y prime negative or x prime negative? Oh, I've got my paper in front of me. It's this one. So I did the same thing here,
It's supposed to be minus sine theta times.
right here.
Oh, God.
Yeah, you're right. I just want to make sure I see why. Derivative of numerator, denominator left alone, derivative of denominator. Okay, yeah, here's what happens. Here's why I've missed this twice. This should be a minus sign because of the quotient rule, but then the derivative of cosine gives you a negative sign, which changes it to a plus, but it was also negative, which changes it back to a negative, which makes this a minus, makes that negative, makes this negative, makes this negative, makes this negative, which makes that negative 1/3. So even though I was trying to be careful, I still did the exact same thing as I did first period. These long questions like this, it's just hard to not make that mistake. I feel like I try to scrunch most of my work into one screen, so of course you guys are always welcome to get a separate sheet of paper if you need to, but that would be my advice. I would not find dy dx in terms of theta. Just find y prime, plug in the value, plug in x prime, find the value, and then divide the values. Y prime at 3 pi over 2 divided by x prime at 3 pi over 2. Okay, I will leave that up for a few minutes. For question 8, though, you might want to jot down that I ended up with square root of 3 over 3. And number 8 should be a little less messy than question 7 was. Yes, I'm listening.
For x, x prime, is this supposed to be minus as well?
Here?
No.
Over here?
Yeah.
It should be minus, but then I took the derivative of the denominator. Derivative of cosine's negative, but then this, you're right, this should be negative also. It's just that,
It doesn't really matter.
yeah, it didn't matter because it was times 0 anyway, so I got lucky.
Mind you.
As I said, some of these are a little bit harder. Obviously, just the questions being longer make them more difficult, but.
Square root of 3 over 3.
Square root of, square root of 3 over 3.
Yeah, that's right. How'd you get it? You just.
Never mind. Never mind, I figured it out.
Whoops. What?
Wait, what is sine of 3 over 5?
That makes sense.
What is sine?
X product. Square root of 3 over 2. So it's 1/2 over square root of 3 over 2. Because sine pi over 3 is 1/2. That's better than square root of 3 over 2. Wait,
Square root of 2 over 3.
square root of 3 over 2.
Yeah, okay.
Cosine 3 pi. Sine is 1. Sine is 1/2.
That's not what I got. I wrote my answer to number 8 on the board if you didn't hear me a minute ago, what it was.
Was that right?
Yeah, you're right. Look what you mean.
So, X should be.
We got the same thing for X. Because you added 2. Because you added, because you added these 2. Negative sign, add these 2. Wait, square it down.
I didn't think it's
Yeah, actually just 2 cosine, or negative 2 cosine sine. Negative 2 cosine.
Wait, why is it not?
Yeah, you got it.
Why is it not?
Yeah, I did, 2 sine squared equals 2 cosine minus 2 cosine squared equals 2.
I don't know what it's the same.
Yeah,
Yeah, so square,
negative
square root of 4.
negative square root of 4.
So
It's like this.
it's 1, should be 1/2.
But I didn't.
So yeah, it should be negative 3 over 4.
Negative square root of 4 minus square
It should be negative square root of 3 over 4.
Yeah.
Mr. Townsend, could you scroll to 7 real quick?
So
Yes.
this is 1/2. Yes, that's right.
Okay, thank you.
This is like, he only has 2 horizontal tangents.
Never mind.
You get 2 horizontal tangents.
Yeah. Yeah.
Are you using mean value theorem?
No.
Okay, actually makes sense.
Oh wait, I don't know. What's the instantaneous rate of change of R with respect to theta? So they just want you to take the derivative of this.
Ask me if
You have r, they want r prime. Even easier.
Screw up through.
Yeah.
Because you time screwed up
the
through.
other one there are
Yeah. So you just like. Oh wait, because that's a square.
is that right?
Oh no. Let me get that. There's like counts.
Oh, this looks scary. The amount of time.
It looks like
This is yeah. There's like counts. Oh.
Like if you had
Oh, I see.
really nice
What about
it
paper?
would be horrible. This is rainbow.
I got that.
The only thing I did this is negative time times time plus
And I'm still
you can go
thinking
with the
of
same
it.
thing, so I just combined it into negative two of those. Yes, that's the same.
Is it not that good?
okay, let's pull up his answers.
5 over 3.
No, because you got cosine equals 1/2.
5 over 6. If you add that again, you
I
get 2
got
5 over
cosine
6,
equals
which is
-1/2.
1 5 over 3. Add it again, you get 3 5 over 6, which is 5 over 2.
Oh, you're right. It's not. It's yeah.
4
There's
5 over 6,
I got cosine equals
5 5 over
1,
6, 6 5 over 6, 7 5.
Wait, what was yours?
cosine theta minus 1. I should do cosine theta minus 1.
Oh, well,
Yeah, it's not. It's not. It's not.
the three values that show up on units are 1/2, square root 2, over 2, and square root 2. If you know how those three things compare, 1/2 is greater than 2.
Yeah, isn't that cosine equals?
1/2 is
I'm
5.
sure on the 8.
Wait, no.
Square root 2 is
No,
But
Wait, but-
it's not. It's not. It's not over 4. It's
Yeah, and this one you got 1.7 something. So when I look at this point, it's got the smallest x possible other than 0. So that's a half, comma,
Right, I still use it to like, I use it
You're well. I'm just gonna check my.
And the other thing is, like, I just don't promise you, it's gonna work out for you, but if you get sine is square root 3 over 2.
Wait, but if you get this,
It's not because I got cosine. I got theta.
we got exactly the opposite. So let me.
I got a base that is okay, you got pi.
0. I got 0 and pi and 2 pi over 4. I don't know. Like one is not.
Wait, 0?
What they want you to do is like,
It should be negative.
remember how we got a couple of answers that didn't work with the graph?
Separate by
Look and see when they actually got the original horizontal line.
yeah, I think my internet's not.
Shaggy. You never cut your hair? Sorry.
I was looking at Maddie. You know him? You know Maddie? The rapper?
Okay.
Yeah,
No.
6 covers, like,
Yeah, it's 2 pi over 3, 4 pi over 3.
What? Wait, we're close? I'm not throwing. No.
It's possible. You start off on that.
Yeah, it did.
Yeah, that's.
So wait, I didn't even do why.
Just show you would never get yourself.
Because you only care about vertical tangent lines, so you really only care about the denominator.
You
the
go faster
derivative.
than me.
So doing anything with y prime is a waste of your time. Why?
Oh yeah, because you already did it earlier.
I didn't do this right.
But still,
I did this page on the other day.
Oh, it's just that's the derivative of that square.
Just cosine.
See that?
0. Is it 0,
But
right?
it's not the quotient rule.
Wait, why did I eliminate 0?
It's not the same as the
Oh.
quotient because
Oh, because yeah, if you graph it, it's
right here.
It's
Wait, so we have to always graph it?
You're taking the derivative of the whole thing, sure. But this is just derivative numerator over derivative denominator. It's not quotient rule.
Okay, might have done like
Well, I gave you the answers to a couple of them.
Okay, so
This one's your, that looks fine.
Where was it?
Rationalize it, negative one's good.
It says 0 to 2.
Oh, wow. I guess 11 is much shorter. 11, they want R prime and they gave you R, so you
Yeah, download Instagram again, Patrick.
in terms of data, it's already got that in there.
I just don't know. This is
Yeah, it's in before you
I'm trying to find DYDX.
Nothing on there besides full answers.
Instantaneous reaching of
Oh,
R.
it's just the derivative.
Right, yeah, exactly. That's why it's not as hard as you make it up.
It's Instagram.
Oh, Instagram's funny.
That was just Instagram for you.
So I go for the book.
My Instagram's funny.
Those are the tangent lines kind of nothing DYDX.
Wait, swim like all the same as
I
the
have
shape.
But the rate of change of R is how the radius is changing. It's not the slope at that point. They're at two different
Spitting
things.
out phones.
Is that you, Patrick?
Just gonna go around for like 1 second.
Can I help with anything?
No, that's a
That's a lot of stuff.
that's a with personal.
Bro, how do you do that?
Yeah, I thought I got it wrong. You put this.
Well, they're the same thing. You rationalize that, you get that. Anything I can assist with?
Not at the moment.
Which one's kind of hardest?
12 is hard.
12 and 13 are both.
It's a lot in general. That'd be the hardest one of them.
Those are harder.
Oh, I messed something up
Wait,
too.
and those
This is the type of stuff I showed my,
Oh,
well, this is the type of
interesting.
stuff I used to show my pre-calc classes. So they'd realize calculus is
I didn't
a lot of work.
Yeah. This is the hardest handout I've done.
Oh, I probably messed this up somehow.
Well, it helped if you're paid
And they
attention
give
to
you.
class.
That's true. Okay, stop agreeing with this.
It's not bad. Yeah.
I got that. It's all there. It's an eternity studio. She's just a big chef. Yeah, and that's why God still got her through that.
She's got to study something.
Oh, so maybe she's like you and wise about switch.
It's called
I'll show
conservation.
you what the difference is.
Conservation of power.
Okay.
Would you leave an answer like that in pre-calc class?
It applies to everyone.
Oh, okay.
Like she lies
So
about
in
studying.
pre-calculus, we
Yeah.
all,
I don't study
like
it.
99% of the time we rationalize. That's why the top part is square root of 3 and the bottom part is square root of 3.
Oh, okay, wait,
That's all
I
they
get
did.
it.
They rationalize.
What does that mean?
It means that not everyone's perfect. It means everyone is strong. Everyone is not perfect.
So wise.
Oh, is
And they
this?
give you grades.
With A different plus B.
Yeah.
Yeah.
And they give you
First off, you only care about vertical
Trisha has piano.
whereas the denominator is bigger. So why even bother with why?
Said what I said.
Okay, alright, but you didn't need to.
It's sounded to the best
So
as not
where
very
you
nice.
want to do for x prime?
Oh, is that the one that is December?
What is, like, show me
Yeah.
That's what you do for water.
It's not too bad.
What do you think?
When you just solve it, well, it's these two cancel.
Number 7. It's not a very. It's not very. It's not very.
So just.
The other tip I'll give you.
Interesting, is that your own?
Thing in back here.
Yeah, no.
What other ones do you want to do?
Wait, did you
well,
want
you saw.
to?
Bro, what?
Latest she'll pass.
Negative percent.
How do you?
But then situation.
Wait, can you check 9 and 11 are right?
They give you what you put in over DT.
48 number one.
-1.
That was a long time ago. I don't know.
For sure, you start getting level 10 again. No, but it's not about competition, it's about enjoying it.
Well, I did enjoy it.
Plus, it's just thinking about like.
Wait, who is that?
It was the creative.
Oh, what's his name?
Why is cognitive so hard?
I just heard it.
What's the answer?
I'm just heard it this year.
What's
Is
the
this like
derivative
Connor
of
Coward?
x squared? What is like
A bit closer than that.
2 times x prime.
You should still do it.
Not if it's with x, you don't know the x. You don't know the derivative of x squared?
Yeah.
And if I ask you the same question,
Rating you when you figure next year.
but it's with respect to some other variable, it doesn't matter what it is, because it's math. You still get a 2x, but then you have to include the x prime because you
I don't know, you know, like, I feel like.
He hasn't talked to you.
the derivative of x.
I don't know, I don't know if it's. I don't think
So
it-
where they're getting at is that is,
Because I'm just in like an average.
You're not average.
The average.
when you take the derivative of r.
You're not average.
You get r
Average like
prime.
good though. You're like good.
Bro,
What's the derivative of
I
cosine?
highly doubt you're what they consider the average
Yeah,
band.
you're like
Right.
the average people are
You
like.
just took the derivative of some beta stuff,
No.
sort of with respect to
Like
time.
that. You're
So they're
definitely
different variables, so you need to
If you
take
can
time.
play like that.
And they already
you're
gave
like
it to you, so
already
just plug it in.
It's not that it's a hard question, but you need to understand why.
Okay, you're not Denny though.
And that's the
You are not
end.
better Denny.
Anytime these variables come back, you have
Remember
to.
last year we did it? Last year we just put y prime.
Yeah, I don't know, I feel like last time I
Well,
if you and I like the
last year, you never took the derivative of x with respect to y. So the derivative of y with respect to x alone. This is the typical. This is the pure y.
Y prime.
Yeah.
Yeah, I get it.
Patrick, if Lawson is one beat, it's possible.
Listen, the only person that I know like has actually lessons is Ronnie.
Donnie does not have.
No.
I saw the down.
Said my disc was fucking
Right, Stu.
Oh, yeah,
How do I do that?
He doesn't
I wouldn't do it right now.
He just reads it.
Yeah.
That
doesn't mean you
do it right now.
Yeah, but my teachers reply to emails if I see.
I just pretty much
What?
restart the computer.
Huh?
He doesn't respond to emails. So you could say that.
I'm about to talk about it. Okay, guys, we're under 10 minutes here, so let me tell you where you need to be. We needed to make a small adjustment to the plan. Some of you are not going to hear it, but that's going to be your bad. I would like you to work through. I would like you to work through at least question 12. 12 is a tougher one. I will ask you to do more next time, so if you got past that, that'll just make next class easier. But I'd really like you to do the first 12, check your answers, and try to learn from your mistakes before next class. You do not have to go further than that. Only because this one's a little bit harder, I will adjust and give you a little bit more time. I'm not going to change the agenda because I'm verbally telling you. Okay, second of all, what is the meme? It's a polar bear. Polar coordinates, polar bear. I don't know why I don't know why that one goes with Cartesian coordinates, but okay. And then if you would, we got about 7 minutes. So if you'd rather do the puzzle for today, you can. You guys did the eye test,
Yeah.
yes? Or you tried to figure out which color was different.
Yeah.
So you did this one.
Yes.
Okay. Y'all are further ahead than everybody. Y'all are the first one to do this one. This one, you try to pick out which logo is correct.
I have a logo quiz for you, and your task is to find the correct one. Let's start.
Obviously, you're welcome to
Here's the
keep
first
working on
one.
calculus.
What's the correct Netflix logo? It's this one. I'm sure you got it right. We all like a good show. Let's go on with something a bit harder. Where is the real PayPal? That's the one. You probably stream music every day, but do you remember how many lines Spotify has?
I don't even use Spotify. I know this one.
It's this one, with 3 lines.